Okay, so there's the bell. We are going to be finding distance today, and you can use the Pythagorean theorem to help you find distance. So that's kind of why it's thrown into this chapter. So there's two different ways. The first one is if we have an actual coordinate plane in a picture, we can use the Pythagorean theorem. So we're going to look at this graph first, which I know those of you at home don't have the graphs. Sorry. Let's see, I'll do it that way. Okay, so I'm trying to find the distance between these 2 points right here. We can't count the grids and say, 1, 2, 3, 4, 5, 6. That's not how it works because they don't cross the grids perfectly evenly. That is probably not a word. So what we have to do is we have to turn this into a right triangle. So hopefully by now you guys can see that I would just go down there and over there, and I have my right triangle. So my legs are 3 and 6 because I can count these evenly since they're straight, vertical, and horizontal. So then to find the hypotenuse of this right triangle, or the distance between these 2 points, I'm just going to take 6 squared plus 3 squared, and I get 45, and then I have to square root that. And whenever I square root 45, I get 6.7. So we are close whenever we fake counted, but that's the exact answer. Okay, so let's do one more. Try this one on your own. I know that's going to be hard because you can't really physically make your right triangle. Here is the hypotenuse, or the distance between those 2 points. So pause it and try to see if you can figure out how far over, how far, what not. Okay, hopefully you've paused it. Your right triangle should look like that with legs of a 3 and 4. Okay, if you didn't get that, your legs are 3 and 4. So now try to figure out what your hypotenuse or distance is between those 2 points. Okay, hopefully you pause that. 3 squared plus 4 squared, that gives you 25. The square root of 25 is 5. So 5 is your answer on that one. All right, so that is the easy way, I think, using the Pythagorean theorem. And then we have the not so easy way, and that is way number 2, using the distance formula. The distance formula, which you can't see what I'm writing. Okay, so the distance formula is this. It looks really intimidating. But I promise once we kind of get into it, it's not that bad. These are the only things that you're plugging in are the numbers. And you've seen these x1s, x2s, y2, y1s before whenever we were doing slope. It's the same thing because essentially this is the slope of a line as well. Okay, so let's just jump into our first example. I'm all over the place today. Find the distance between 2.5, 3.5, and 1.5, 4.5. Okay, we have a couple steps to do. Step 1 is to label points. Okay, we've done this a million times. This is x1, that's y1, x2, y2. So whenever I say label points, that's all that I mean right there. Okay, step 2 is plug into the formula. So I'm going to set up my formula with everything but the numbers that I've highlighted. So I got all of that in there. And now I'm plugging in these numbers. So I look at x2 goes first. x2 is 1.5, so I put 1.5 there. x1 is 2.5. y2 is 4.5. And y1 is 3.5. Okay, so I plugged in all of my numbers. If you need to go back and rewatch that so you can kind of piece together where all of these came from, go ahead and do that. Okay, order of operations tells me that I need to do what next? Let's squeeze this in here. Step 3, I need to subtract what's in parentheses. So 1.5 minus 2.5 is -1. I still have to keep the parentheses around it because that's being squared. Plus, what's 4.5 minus 3.5? 1. Okay, now order of operations next tells me that I need to square both of these. So I'm going to go to the next page to do that. What step am I on now? Step 4 is to square. So if I take 1 squared, I get 1. Or -1 squared, I get 1. Plus 1 squared, I get 1. Okay, and then from there, step 5 should be pretty obvious. I'm going to add. So square root of 2. And then my last step is to square root. And the square root of 2 is 1.4. So lots of steps, but it's just kind of the steps that make sense as you're going through and solving this. You're going to do the subtraction in parentheses first, then you're going to square them, then you're going to add them, and then you square root. So I want you to try this one on your own. This is the last one. Find the distance between 3, 2, 4, 5. So I want you to pause this, really try to set up your formula, label your points. Let's do that first. Label points first. Okay, that should be what you get whenever you label your points. Now set up your formula. I'm setting it up. Hopefully you are too. Okay, whenever you set it up, it should look like that. Now plug in your points. Okay, plugged in points should be that. Now subtract. You should get that. Now we square. You should get that. Now we add. You should get that. And last step is square root that. And then you should get 3.2. All right, that is it for today.